Okay, hi everyone. So in this video, we're going to review exit past 10 from 1D, and we're going to talk for trigonometric functions of any angles or in general angles. So we'll be using our ASTC for this work, and we're going to solve complicated questions from here. So question 1, we have the diagram shows the point P, reflex angle and reference angle alpha. So evaluate sine theta, cos theta, tangent theta. Okay, sure. So over here, right, what you can do is, let's do this. Okay, so sine theta, right, sine theta will be equals to sine alpha. Okay, we can borrow the reference angle or the basic angle alpha. However, in quadrant 3, this is negative. Sine is negative, so we have a negative of opposite. Oh, before this, okay, negative 3, negative 4 means that the x is negative 3. So I'm going to put a 3 over here, disregarding the signs because I think you'll be confused in the end. And the y will be 4, so I'm going to put a 4 over here. Y is negative 4, so this has a length of 4. Right? So over here, so the opposite, then the hypotenuse would be 5, 3, 4, 5, right? So then negative or sine alpha would be sine of opposite over hypo, so it will be negative 4 over 5, like this. Okay, next, cosine of theta. Cosine of theta would be equals to cosine of the basic angle alpha, and just nice, in quadrant 3, alpha, cosine is negative, so I'm going to put a negative in front. Okay, then cosine is 3 over 5, so it's negative 3 over 5. Negative adjacent over hypotenuse. Last, tangent theta is the same. I can equal this to tangent alpha, basic angle. But in quadrant 3, it's going to be positive. So I'm going to just leave it as it is. So tangent would be opposite over adjacent, 4 over 3. Okay, so hence find the value of alpha and theta in degrees. So, right, because whatever that we're doing over here, this one, right, is sine basic angle is 4 over 5, right? Cos basic angle is 3 over 5. So what I do is, and then cos this, right, is equals to negative 3 over 5. So what I tend to do is, we need to look for the basic angle first, right? So this will build our foundation for the later part when we solve for angle. So we look for the basic angle first. So we can use sine, cosine, or tangent, either one, but sine alpha is 4 over 5 based on that small right angle triangle. Okay, so alpha over here, right, alpha over here would be sine inverse of 4 over 5, right? So in degrees, this will give me 53.1 degrees. Okay, then last but not least, the theta, the full angle, it is 180. Do you see this? Okay, okay, so this will be 180 plus another alpha. You see this? So this would be 180 plus alpha 53.1. So I will get 233.1 degrees. So you take note, yeah, for this one over here is the one above, this diagram above over here, right? You notice that I didn't assign negative 3 over here. You didn't notice that I didn't assign the negative 4 over here, even though previously I've told you to do so, precisely because we are already following ASTC, so it doesn't make sense to confuse and double the negative, right? So to prevent double negative or to do double steps, we are just going to leave the ASTC to our own. We are going to leave this to decide on the signs, and the triangles from now on I'm going to just put there as the lengths itself. Okay, now however, if you want to think in terms of the, what do you call this, if you want to think in terms of the angle itself, then relate directly to this triangle, right? Then yeah, then go for, by all means, go for it. Otherwise, for me, I would just stick to 3, 4, 5 and not thinking about the negative. The negative 3 and negative 4 will tell me where's the P, where's the point, and what's the big angle, but that won't interfere to my ASTC when I evaluate the answer. Okay, so just want to do a disclaimer first. Okay, now question 2, right? Given that, okay, we have this one over here, right? So means that this is in quadrant 4. Okay, this is going to be in quadrant number 4. And that sine A is negative 5 over 13. Okay, so let us draw this diagram. Right, let's draw this diagram out. Quadrant 4. Okay, I have an angle over here. Now, this big angle here is A, right? Sine A, right? However, I'm going to need to borrow a basic angle over here to the horizontal x-axis. Okay, and with this, I can have a right angle triangle. Right, I can draw a right angle triangle over here. Now, opposite over adjacent is 5 over opposite over hypo is 5 over 13, which means that the adjacent side would be 12. This is a 5, 12, 13 triangle. Okay, so find the value of cos A and tangent A without using a calculator. So what is cos A? I can borrow it using the basic angle. Is equals to cos alpha. So cos alpha is adjacent over hypo. So adjacent is 12, hypo is 13. Okay, next one, tangent A. Tangent A, I can borrow the basic angle, tangent alpha, but in quadrant 4, ASTC, tangent would be negative. So over here, you'll be negative opposite over adjacent, 5 over 12, negative 5 over 12. Okay, so you see, right, I don't need to care about the negative because it's going to be very confusing. So apologies for introducing that earlier in the first place, but it's going to be very confusing. So my suggestion is just go straight to the length, okay, and then we just negative from ASTC. Okay, next, number 3, given that pi over 2 theta is between pi over 2 and 2 pi, which means, okay, this sentence means it will be between quadrants, quadrant 2, quadrant 3, and quadrant 4. Okay, now then tangent theta is 3 over 4. Then tangent theta is positive, you see. So from this one over here, right, this is quadrant 1 and quadrant 3. Okay, so between these two sets, which is the common quadrant? The common quadrant is actually quadrant number 3. So for me, right, I'm just going to like focus on quadrant number 3. It will be in quadrant 3. Okay, so let me draw out an angle in quadrant 3 and then we see what to do with it later. Okay, so we have this angle over here. So this big angle is theta. Right, from the east, this big angle is theta. Then from the horizontal line, the basic angle is alpha. Okay, so let me draw out the right angle triangle over here. So based on this right angle triangle, the tangent is 3 over 4, right? So opposite over adjacent. So this will be opposite adjacent. The hypotenuse is 5. So this is a 3, 4, 5 triangle. Okay, so what is sine theta? Sine theta I can be equals to sine alpha, but in quadrant 3, ASTC, so sine would be negative. Okay, so this one will be opposite over hypo, so negative 3 over 5. Next, cosine theta is equals to, same thing, cosine alpha, I can borrow the basic angle. ASTC, third quadrant, is negative for cosine. So here will be negative adjacent over hypo, negative 4 over 5. That's all. Okay, very simple. Number 4, given that tangent A and cosine B is this, where A and B are angles in the same quadrant. Find the value of each of the following without using a calculator. So our goal is to find the where is A and where is B first. Very important. So let's do this. So over here, tangent A is negative 5 over 12. So means that tangent A would belong to quadrant 2 and quadrant 4 because tangent is negative in 2 and 4. Cosine B is negative, so this would be in quadrant 2 and quadrant 3. So which is the common quadrant? So over here would be quadrant 2 over here. Okay, can so we just look at the signs of tangent A, we look at the sign of cosine B, then we try to identify which quadrant is this. Okay, because we have A and B, we have two separate angles to draw. So let's draw this out. Okay, very easy. So this is A, right? This is A. and the basic angle, I'm going to call it alpha. Okay, basic angle, I call it alpha, right? Like that. Okay, right, so I have this. Okay, let's see. Can okay, so this one is alpha. So tangent A is negative 5 over 12. So the opposite over adjacent is 5 over 12. Then the hypo would be 5, 12, 13. This is a 5, 12, 13 triangle. Okay, now the next triangle over here would be for B. This is quadrant 2, sorry. Okay, quadrant 2, let me redraw this in quadrant 2. Oh dear. Okay, quadrant 2. Okay, so this is A. Okay, right angle triangle to the length. So this is going to be alpha. Opposite over adjacent. Then the hypo is 13. Okay, we are ready for B. So same thing, we can draw the same, roughly the same diagram. Okay, roughly lah, roughly. Okay, so over here, now this angle is angle B. So the basic angle, I'm going to call this basic angle beta, alpha beta. Okay, so cosine is 1 over root 3. So the adjacent over hypo is root 3. So actually this is our very special triangle, right? No. Okay, no. Okay, so this one would be 3 square minus 1 square. So this is actually root 2. Okay, root 2. If you were to see what is this, okay, so this length over here, this would be root 3 square minus 1 square square root. So this would be 3 minus 1, right? So this is equals to root 2. Okay, so this length is root 2. Okay, sure. Let's go on. Let's move on ahead. So sine A would be equals to sine alpha. I can borrow from basic angle sine alpha. In quadrant 2, sine is positive, so I'll just leave it like that. So sine is opposite over hypo, 5 over 13. Now cosine of A is equals to cosine of alpha, but in quadrant 2, cosine is negative. So over here will be negative opposite over adjacent, so negative 4 over 13. Okay, for sine B, let's look at sine B. Sine B is equals to sine basic angle beta. In quadrant 2, sine is going to be positive, so I will just leave it like that. So the answer is opposite, which is root 2 over hypo, which is root 3. So rationalize, I will get root 6 over 3. Okay, so tangent B, okay, in case if it's too fast, rationalize, okay, rationalize like this. Right, rationalize, so this would be root 6 over 3. Okay, tangent B, I can borrow tangent beta. In quadrant 2, tangent is negative. Okay, so this one over here would be opposite over adjacent, so it's just root 2, simple, and negative root 2. Okay, just like that for question 4. Okay, last for question 5. Is there any to question 5? Okay, no more. So that's all for this exit pass. Okay, bye bye.